Welcome to the CAD Office Training Guide series for FDOTConnect. I'm Heather Purin, Structural Engineer at WSP USA. Today, I'll be going through the OpenBridge Modeler Training Volume 1, Introduction to Model-Centric Design. In this series of videos, we'll take you step by step through each exercise from the guide. In this session, we'll go through Exercise 4.1, including incorporating roadway and survey data into our design file. The topics that we're going to cover in this video are the importance of data connectivity between disciplines for a bridge model and fully going through exercise 4.1, including attaching an alignment and attaching a 3D survey file. We'll also discuss other legacy methods of data import. Let's begin. Before we get started on exercise 4.1, we wanted to touch a little on the importance of data connectivity. Data connectivity is a vital part of the design process, especially for bridge modeling. Bridge design and modeling requires collaboration between roadway, survey, geotech, structures, and other disciplines to make sure that we have a bridge that fits into the larger picture of the overall project and the surrounding area. The roadway information is particularly important for bridge modeling because an alignment and profile must be defined before starting any bridge model in OBM. If an alignment file is not established in ORD, there are tools within OBM to create a working alignment or profile, or you can import one based on a GPK or land XML file provided by Roadway. If you're early in the roadway design process, or if there are significant changes that are anticipated to the roadway alignment and profile, you could work with one of the ones that are generated within OBM, and then once the final roadway information is established, it can be imported as it's refined. You can always change the alignment of a bridge within OBM by going to Home, Bridge Setup, and Alignment. Something to keep in mind is that with each roadway change, the bridge will be updated automatically and adjustments will be made to the bridge model. There'll be a notice for this within your attachments dialog box, similarly to MicroStation. There should be an exclamation point to alert you that there has been a change in your reference information. Once you accept that change, it'll go ahead and update the bridge model automatically, but it doesn't always do it perfectly. So you'll have to make sure that you verify that any changes were incorporated properly and that the updates didn't trickle down to the bridge incorrectly. We can also attach survey and topo information. These are not as important necessarily because they're not required to create a bridge model in OBM, but they are helpful for understanding the existing conditions. So it's nice to be able to see the interaction between the proposed information in the model and the existing conditions. You can also set the footing elevations based on the existing ground data if you would like, or you can set those manually based on an elevation that you calculate separately. Let's go ahead and get started on exercise 4.1. Exercise 4.1 involves attaching as references the roadway and survey data that we're going to use to create our bridge model. Now, the first step in the exercise is to open up the 4.1_begin DGN that is a part of the dataset that was provided. Now you're going to see that in this case, it's basically a blank DGN, but in general, we're always going to open up the exercise_begin that has been provided in the dataset to make sure that we're all on the same page as we get started with the exercise. Now we're going to attach our references under the OpenBridge Modeler workflow within the Home tab and the primary group. We're going to open up our references. So within our reference dialog box, you can go to Tools, Attach, or you can right-click in the open space and click Attach. The first file that we're going to attach is our alignment file that has been generated for us in ORD. The model that we're going to use is just the default model. We're going to click OK. As you can see, when we attach the DGN, it actually attached two files here. Two models. The first model is the default model, and that's the horizontal alignment. The second model is the default 3D model, and that's the vertical profile. In ORD, everything is set up in 2D, and then a 3D profile is created from that 2D file. So when we attach the default model, we'll get both of these model attachments here. As you can see, if you zoom in, the alignments are already annotated, so we do not need to do that step, but we will go over how to annotate alignments if it's needed, if you're going to import them using one of the legacy methods. Within the Analysis and Reporting tab, you can change the scale here, the annotation scale, if you'd like. You can make it smaller if you need, or you can make it bigger. The annotation scale is something that within OpenBridge Modeler has been improved upon from MicroStation. In MicroStation, you would need different models that had the different scales within them for annotation. When the alignments are created in ORD now, it's more dynamic. So once it's attached as a reference, you can go ahead and change it without needing to change the reference itself. So that's a good change between MicroStation and ORD OBM. For this model, we do also have to attach the super elevation. So we will right click and we will attach the same DGN here. Double click or click and select open. Then for the model, we will select the super elevation left model, and then we will attach it. So as you can see in the 3D model view here, we now have this super elevation section shown, and we are going to use that to define and establish the super elevation that occurs within the bridge. We're going to go over that more in exercise 5.1, but the first step in the process is to attach it as a reference here. Once we have all of our roadway references attached, we're going to go ahead and incorporate survey data. Let's go ahead and not display the super elevation section just to make it a little bit cleaner. So we are going to right click, attach, and then we are going to attach this GDTM BR01 file. And this is a survey or terrain file that has been created for us for use in the bridge model, which is ideally how it works. We've only got one model within here, so we'll select OK to go ahead and attach it. And we will go through legacy method of attaching the survey information if we do not have this GDTM bridge files. So as you can see here, we have our all of our information. Let's go ahead and take a look at it just in our 2D view. So we'll go up here in our view options to fit view, and we'll see basically everything that we have just attached, the limits of our alignment file and our survey file. So as you zoom in, you can see the different triangles that are used to represent different elevations. We can take a look at it in 3D as well. So we can kind of pan through here and rotate through to see that these are in fact changes in elevation. Since we're in Florida, there is not a significant change in elevation here, but as you get closer in, you can see that that there's a little bit of variation here. So we can view the terrain model in a couple different ways. So we'll select it here and then right click and open up the properties. Once the properties pull up, we'll be able to on the right here for the properties, for reference,
under override symbology. Right now it's set as no, which means it's basically going to display however it displays within the DGN itself. But if we change that to yes, now these calculated feature display and source feature display are no longer grayed out, so we can change them. So we can toggle on and off the major contours, minor contours, the triangles, break line, boundary. So if you toggle on the major contours, you'll see the dashed or the dotted red lines come in, and then the minor contours, if you turn them on, are represented by dotted yellow line here. So we don't really need those as a visual representation, but you could also turn off the triangles here, which if the program is running slow or if you're panning around the program slowly, sometimes it's because the triangles are turned on, which that takes a lot of processing as you pan through. So if you'd like it to move a little bit quicker, you can go ahead and toggle off the triangles. Make sure you keep the boundary on though, so that you can see the limits of the terrain file as you are working within your project. So something that you can also take a look at, for a second we'll turn the triangles back on, and if you zoom in, and if you toggle on break lines here, then you can see the white dashed lines, which actually are easier to see if you turn the triangles off. But these white dotted line here are their break lines, which are used to represent an edge of pavement or ditch bottom or any other abrupt change in slope. The triangles, when you toggle them on, you'll notice that they do not cross over break lines, which basically keeps the mesh of the triangles from averaging elevations that are very different or too far apart from each other. So moving forward, we're going to go ahead and toggle off the triangles, toggle off the break lines, and just keep on the limits here, the boundary limits. And for display purposes, we'll just toggle that off for now, since we won't be using it in the immediate future. Once you have all of your view settings the way that you'd like them to be displayed moving forward, make sure you go to File, Save Settings, and that'll keep everything displayed as you had just set them when you close down the file and then open it up again. The last thing that we're going to go over are some of the legacy methods of importing alignment and survey or terrain files into OpenBridge Modeler. Now, the steps for what we're about to go over are detailed in Chapter 4 of the training guide, but since we had the alignment and survey files directly provided for our example 4.1, I'm going to show you how the legacy methods work in a separate instance of OBM in a work set outside of our exercises in Dataset. So we are currently operating as if our alignment file does not exist for us to reference, and we're going to have to create our own. So that's why I've got our blank file DGN open. So if you need to create an alignment file, you will use the FDOT create file tool. The discipline will stay structures because the alignment file is only going to be used for our bridge model, and for file group we're going to use a structures design file. So as you can see, that will pull our 2D seed file because we are selecting an alignment file here within the file type. So let's go ahead and create this alignment file and open it up. So for our example of going over a legacy method, we are going to import our alignment using a GPK file. So this would be if your roadway folks had provided a GPK file but had not generated an alignment file in ORD. So once you are in your newly created bridge alignment file, you'll go to the Home tab within OpenBridge Modeler Workflow, and under Bridge Setup, there is an import option here. So within the drop-down, we can select Geometry, and that's going to open up an Explorer within your work set. So this is just a test work set that I created, but we can open up within the Roadway folder your GPK file that you've been provided. Now when we import the geometry, you're going to have a dialog box that opens up, and it's going to give you the option to import just about everything that exists for that GPK file. In our case, we're just going to import the one profile that we're interested in. You can keep the Create Civil Rules checked, and then select Import. Once you've imported the geometry, you should have an alignment that has come in and is now live within your file here. We've imported it. So after you have imported the alignment, as you can see, there's no stationing or annotation or anything. So we're going to have to add that ourselves. But the first step before we can add that is to make sure we assign our feature definition. So we can select the alignment that we've just brought in, and then right-click and open up the properties. And once the properties dialog box has opened up on the right-hand side, we are going to assign a feature definition to our alignment that we just imported. So we will drop down here, Feature. As you can see currently, it says no feature definition. We're going to assign a feature definition that we can annotate the alignment and add the stationing to it that is already inherently within the GPK file. So now for alignment, we can select either baseline or center line for our feature definition, and we are now assigned this feature definition here. So now that we've got the feature definition assigned, we can go to Analysis and Reporting, and for our annotation scale, we'll keep it at 1 inch equals 50 feet, and then you can either use model annotation if you want to annotate everything within the model, or element annotation if you'd like to specifically select which alignment you're annotating. So we will select our alignment, and as you can see, it's now been annotated with the station tick marks, and as before, we could make those smaller or larger depending on our needs and the scale that we require for our project. If you'd like to create a survey file with ground line elevations, but you did not have the GDTM provided, but you do have a TIN file available, you can create a survey file. It'll be similar to the way that we created an alignment file. So we'll GN within the FDOT tab, Create File tool. Under the Structures Discipline and again Structures Design files, there's also a GDTM bridge file option. So let's go ahead and create one of those files. Now once we have our blank file that's ready, we can import the terrain. So within the Home tab, under Bridge Setup, Import drop-down, we can select Terrain, and it'll bring up a File Explorer. We can navigate to our Legacy Import Test, which is where we've got our TIN file stored. And again, this is just an example. This is not a part of the data set. This is just to show the legacy methods. So within the survey folder, we'll have a TIN file here that we can open up. You can also sort by different file types depending on what file you're using to import the terrain. So if we select Done, there'll be an Import Terrain Model dialog box that pops up. Now for importing terrain, you have the target up here, which tells you the coordinate system that you're using, and then down here under File Options, some of these may be pre-populated, but in our case, for the source file units, we'll select US Survey Feet. And unlike alignment, we can assign the feature definition right as we import it. And I believe in future versions of OBM, there will be a similar option to assign the feature definitions as you import the geometry for alignments, but that is currently not available. So we can go ahead and assign our feature definition as existing. So under terrain, there'll be various options, but we can go ahead and select DTM existing and then select import. Now once we've imported our terrain, we can close out of that dialog box. We can do a fit view, and as you can see, we've got a terrain model here that we've imported. If we toggle on the triangles, you'll see that we do have some elevation information provided here. Now this is a survey and terrain file that we've just created based on the TIN file. We could also be provided a topography file that is different. This is ground line elevations, and a topography file will give you additional existing features, including pavement, utilities, trees, etc. Thank you for joining me today for the CAD Office series for FDOTConnect. This was exercise 4.1, incorporating roadway and survey data for the OBM Intro to Model-Centric Design Guide. In the next video, we'll go through exercise 5.1, building a bridge model.